Good morning all. Today I'm going to take a look at the contents of this envelope, which I've already opened. Sender's address is there. Didn't think I should show that. And it's this device, which I got from a seller in the UK. And I've got a couple more of these coming. They're all slightly different because this is kind of the main switching element for my solar, battery and cryptocurrency mining setup. While I'm gabbing, I might as well open it. This is the switcher that will switch on the cryptocurrency miner when the battery voltage is low and switch it off. No, the other way around. Switch on the miner when the battery voltage is high and switch it off when it's low. In other words, it is a discharge load controller. So as I understand it, what you can do with this thing, where's my pointer? Is set an upper voltage threshold with these 4 buttons down here. This incidentally is an XL semi switching regulator of some sort, and there's a little inductor. But the main microcontroller is actually under the display there. I don't know whether I'm going to be able to show that. I could just see rows of pins. I can't really illuminate it in such a way that you can see it, but it is, oh yeah, there we are. I think you can just see the pins along one edge. So the microcontroller's under there. Now it's going to be doing voltage measurement and also driving that display. Yeah, so you set your upper voltage limit and your lower voltage limit, and I believe there are 2 modes. You can either set it so that it's a charge controller, so that when the battery gets to a low potential, the relay will kick in and you can have a mains or whatever charger coming in to charge the battery back up. And then when the battery gets high, the relay will drop out. But you can also set the other mode, which is a discharge controller. So when the battery gets to a certain high state of charge, you can turn the relay on. That will then discharge the battery into a load. And that's precisely what my system does. I want the battery to charge from solar and then discharge into the cryptocurrency miner, so that the solar panel's never sitting there doing nothing. I want it to be working all the time. So let's power this up and take a look at these upper and lower settings and see if the relay kicks in. I do believe that this is V in and ground for power, to power this thing. And I think it's got quite a wide range. I think it was 4 to 40 or something. This is V in for measuring the voltage. And I think what you do is strap the V minus there to ground. They're probably linked on the board. Yes, they are. Look, V minus to ground. And this, I think, goes up to 30 volts. And then the relay, you've got normally closed and normally open connections at a common center tap, which will be that one. Are these separate connections here? So you connect it all up yourself. Yeah, let's power it up through there. So I'm going to connect this connector now, V in positive, so that'll go upside down like so, and I'll stick 12 volts in it. I believe it is 4 to 40 on the input. Oh, that screwdriver's no good. So here's one of the connection diagrams. Oh, it's 6 to 40 on the input. Well, that's fine. From eBay. And we have the fire line and the 0 line. So positive and negative, you put your positive through the relay. The normally open would be my guess. That goes into your charger and that charges your battery, with the device measuring the battery voltage on this input and this input just supplying power to this relay unit. So let's just supply power to the relay unit and watch the display come on. Right, 12 volts from the batteries outside my window. And there it is, and it says U-1. Of course, we're going to have the usual problem here, but you can't really see the display. I'll get some red insulation tape on there. Peel this one off, because we don't really want 2 layers of this stuff. And cut a bit of red and stick it on. Now, can we see that better on camera? Oh yeah, that's better. So it says U1 and now 0.0. Ooh, up. No, down. Doesn't do anything. Oh, switches the dot on and off. Interesting. I don't know what I'm doing at the moment. This is the usual story. set U1, fine, up, U2. Oh, so that's the different modes. Now I'll print those out actually because they're quite interesting. So here are the 6 modes. They're rather small, sorry about that. Okay, U1, charging measurement. When the measured voltage is lower than the lower limit, the relay pulls. Above the upper limit voltage, the relay... Oh, it's cut off. Well, the relay will drop out, I presume. Right. Charge measurement time control. So you can probably set a timer. Not interested in that. Discharge detection. When the measured voltage is lower than the lower voltage limit, the relay is off. Above the upper voltage limit, the relay pulls. Don't think we want that. I don't think we want discharge time detection, time control. Voltage in the range and voltage outside the interval, outside the range. Oh, well, actually, then maybe we want discharge detection. When the measured voltage is lower than the lower limit voltage, the relay is off. Lower than the lower limit, yeah, the relay turns off. Above the upper limit voltage, the relay pulls. So that looks like the one we want, U3. So let's go up to U3. There it is. And what do? Do we press set? Oh, NL1, 0. So let's set this to about 3 volts. Good, it's got a... Oh, that speeds up, which is interesting. It's only accurate to 0.1 of a volt, but that might be okay. Set UL upper limit 1. Now, why would it be 1? Well, I'll set that to, I don't know, 4 volts. And I presume it remembers all this stuff in the non-volatile memory of the chip. Set NL1, 3, UL1 upper limit. What's NL then? Lower limit? Minimum limit? ML is it? It says NL. Is it ML? I don't know. Stop. Stop. No, stop doesn't do anything. Set. Set doesn't do anything. I'm stuck. Maybe you have to unplug it. You're bored now, so I'm going to try and play with this, work out what I'm doing, and I'll be back. Right, so I've gone into the menu and set it for the 3 volts lower limit and the 4 volts upper limit. I've put a 100 microfarad capacitor on the measuring input and a 10k resistor so that I can charge that capacitor. So let's charge it and take it above 4 volts. Oh, it went up quite quickly. The relay pulls in. When it goes down below 3 volts, the relay drops out. Let's try and widen. Why did that go up so quickly when I touched it on there? I suppose it is 12 volts. Maybe I'll have a higher resistor than 10k. But yes, that certainly seems to work. Below 3 and the relay drops out. Oh, is there a little light on there? Did I see? Yes, there is. There's a blue LED, so you can see what the relay is doing. Down below 3 volts. And that drops out. Good, okay, let's set it to a wider range. Apparently to set it you have to press and hold, but then you have to let go. So it's slightly odd. So it's U3, it's in the mode that I want. Now NL is lower limit. I don't know why NL is lower limit, but it is. So let's bring that down to 2 volts. And then we'll go upper limit, and we'll take that up to, I don't know, 6 volts. So we've got a wider range. NL 2. Oh, it's not going to tell me. I think it's done. So let's press and hold set. I think that's what you do. And we're back to U3. So now it should trigger at 6 volts. There it goes. And then it should drop out when the capacitor voltage drops below, I think I set it to 2 volts, didn't I? Yes, I need a higher value resistor here. I'm going to get a 100k. Right, with the 100k, that is definitely going up slower. So we need it to get to 6 volts to trigger the relay to its on state. Oh, that's going up really slowly. I mean, have I got dodgy cable here or something? Probably. I think I have. Oh, or is the input impedance of this overwhelming? No, it's got to be a dodgy cable, hasn't it? I'll use another cable. Right, I've got a 20k resistor. It's 0.1%. That doesn't particularly matter. Okay, let's take it up. Up it shoots above 6 volts, which I set the upper limit to. The capacitor voltage decays, and below 2 volts, the relay drops out. Right, so you get the point. That's that. I suppose we could try another mode. So the charging measurement is U1. Let's set that one. So press and hold set, down to U1, set, lower limit. Well, that can be 2 volts. Well, the limits can be the same actually. Set. Do I have to change that slightly? 2.1 set. Yes, I do. That's really stupid. Upper limit 6. Well, let's go to 5.9. Set. I think we have to press and hold set. Right, so the relay has now pulled in because it's below my lower limit of around 2 volts. Let's take it up to my upper limit and the relay drops out. So this would be if you were charging the battery. The battery's getting low now. Oh, it's going really low. And so your external charger is now switched on through the relay and will charge the battery back up. So let's charge the battery back up. And when it gets to 6 volts, the charger cuts out and then the battery is allowed to slowly discharge. But this upper limit and lower limit thing means that you can set a really large hysteresis. And that's going to be fine for turning on my ant miner when the battery, my lithium iron phosphate battery, reaches a certain voltage. And I'm kind of thinking about 27.5 volts for the upper limit and probably about 22.5 volts for the lower limit, but that's just what's in my mind at the moment. Let's just do one more of these. Voltage in the range, which is U5. Press and hold the set. U5 set. I don't know. No, I think we've come out. Press and hold set. U5. But I don't know what to do now. Do you go up? No, that's change. No, it must be set. Oh, there we are. So the lower limit is 2.1. So we'll leave those limits the same and come out of that. No, that wasn't long enough. But you don't get the feedback. You just have to hold it for 2 seconds and hope that you're right. So voltage in the range. Now, as we go through the range 2 to 6 volts, the relay should come on. So it came on and went back off. And then as we fall back down into the range, the relay is on. And as it drops out of the bottom of the range, the relay goes off. And then the other one, U6, there's no point doing that. It's the other way around, outside of the range. Yes, I mean, it's got a reasonable set of working parameters. Now, one possible problem I foresee is this 10 amp relay. My ant miner probably pulls getting on for 20 amps at 12 volts. So at 24 volts, it's going to be around 10 amps. So this relay is going to be working close to its upper limit. I really wanted one with a 30 amp relay, and I have subsequently found one that's coming from China. This one came from a UK seller. I'll put a link in the description below because I just wanted to get hold of it quickly. And I think this is going to kind of do the job for now. Now, apparently you can connect V in and measure positive together, and the 2 grounds are connected anyway. And that allows you to use the measured voltage also as the supply voltage. And I think that's fine because the V in was 6 to 40. Well, that's my battery is within that range, so that's fine. And then the relay is going to turn on the power to the ant miner when it's within my ranges. So I suppose I should set my voltage ranges really. I know that I want U3, which is this discharge detection mode. Lower limit I think is 22.5. So let's, oh yes, that goes quite quick. Okay, it's all a bit quick. 22.5, let's set that. Upper limit, I think, was 27.5. Oh, it does go very quickly. 27.5, set. Up, lower limit, 22.5. Well, that's fine, so I think I can come out of that. What if you press stop? No, that doesn't do anything, which is really annoying. Right, I'm out. It's very weird, this. I want to come out. No, I've got all that. I know all that stuff. It's all in there. But how do I get out? Oh, driving me mad. Oh, it's out. Now this stop button, it says off or on. Well, it doesn't apply to the relay. I wonder if it applies to these. There's a couple of connections up here. We've got an output and a ground, and I think you can control something else with those. Actually, that could be quite handy because you could probably control a 30 amp relay board with that. But there's also this TX and RX, and I think it can send out data on TX and RX. I have to put a scope on there, I suppose. Probably showing the measured voltage. Interesting. Look what I found! A little miniature oscilloscope. I don't really remember who sent me this, so if you sent it to me, well, thank you. It's convenient because it fits on my desk. Look at that, Aron Tech. So it comes with a probe which plugs in to the top. I'm just wondering if I can see anything coming out of the... That should be alright, because if that swings up and shorts the cap, it doesn't really matter, does it? I want to see what's coming out of the TX. Anything? Oh, I think we saw something. Yeah, now, can I vary the time base? Oh, possibly. I'll have a play, see if I can get this to work. Right, after much fiddling about, I've now got the serial data on the TX line going into the scope. It's triggering properly. That red mark is the trigger. I could put it on 2 milliseconds per division, but then you can't see all the data. On 5 milliseconds per division, you can see it all. And it seems that it sends a burst of serial data, I think every 1 second, it said in the instructions on the eBay listing, but it's certainly sending something out. Yes, it is still triggering. That is still changing. So yes, you can get a burst of serial data. Parameters like, I think, the timers and the measured voltage. If I push the measured voltage up, we might see, I'll put it on 5 milliseconds, we might see some changes to the data as the voltage drops back down, but of course this doesn't have any sort of serial data interpretation software in it, but it shows that it can be done. The next thing I want to do is put a little LED with resistor across that secondary output and see if it mimics what the relay is doing. And I've set this back to 2 volts and I think 5 volts for the lower and upper limits. I've put a blue LED on there with a resistor, and now if I take it above the upper limit of 5 volts, the LED comes on and it just mirrors this LED here, and when it drifts back below 2 volts they both go off. So yes, this is just a method of daisy chaining to another unit. So that could be one of those little 30 amp relay boards, which could be quite handy. So now I need to connect the voltage switching device through to the buck converter. This will switch at the 24 volts, hopefully under 10 amps. So what I want here is I want switched high current positive to come into common and go out of normally closed. I also want that positive line to go into voltage measure and also to go into here, which is the power source for this module. Then ground will just bypass this unit, but it must also have a wire feed into the negative point here to provide power to this unit. So I'm going to make this up in XT90 so that this can be inserted into my line of cabling. So this is my current male to female cable, which runs into the buck converter. So what I want to do is cut the red, put that in normally open. The black will run through to the connector on the other side, but I'll need a thin black coming out to provide a ground reference for this, and I'll need two thin reds coming out. The thick red actually will need to run into common here. I need another red running across to there, which I can probably just daisy chain across, but I'll need another red coming out of this side to run into the supply input. Now I've got a number of these things. It's just a sort of pin which you can crimp on. Of course I solder them, and I found one in blue, and so I've put it on there, and it fits quite well in this. These are very small diameter apertures for these terminal blocks, but I haven't got any more of these blue ones. I've only found one, so the red that comes round and goes into there I'll have to do some other way. It's all going to be a bit haphazard, this one, unfortunately. Right, the only other blue one that I could find in this fishing tackle box, which only now has yellows and reds, was this fork terminal. So I just cut that off, and that blade will fit in there. It's very ugly, but it's all I've got. Right, it's finished, but this is terribly messy because the board is just laid out in such a way that everything's, yes, well, you can see, can't you? But anyway, incoming positive, that goes into the common of the relay via this connector, which was the only one I had. Outcoming is normally open, so that will close and provide power to there. That provides power to my buck converter to take the 24 volts down to 12. Also got a couple of wire feeds into here to power this unit, and the wire here takes positive of my battery and puts it into the measurement input. Don't need to bother with the ground, so that should work. Time to take it out to the shed. One other thing, I need a coupler to put the solar in, and that goes to the that goes to the battery. Oh, is that the solar? Oh, have I done this wrong? Oh, I don't think so. Solar, battery, and on to the rest of the circuit. I think I need to flip that one over actually. Now I'm in luck because it's sunny and there's sun on the panel. So let's hook this up. Now I've hooked up the voltage trigger unit to the battery. I just need to connect the solar in, but this is all rather awkward. This has to go upside down. It has to sit kind of under that, but I'll just mount the camera. Now this hasn't triggered because, oh well, actually there's an on and off thing. That's off, that's on, but it still hasn't triggered because it's 26.6 and I've set it for 27.5. So let's connect solar, which has to sit under here, which isn't ideal, but it should kind of work. Oh yes, that's lifted the battery voltage to enough to switch this on. Yeah, these voltages are shooting up. I think the battery is essentially fully charged, but I'll use this as a pointer. No, I'll use this as a pointer. That's gone to 3.74. The BMS has now turned off. Yeah, this is weird because the solar panel is periodically driving the Antminer directly, and that's not good. I really want to partially cover the solar panel while this is going on actually. But the Antminer is sort of working, but yeah, the BMS is cutting in and out. Not ideal. See if the Antminer does fire up actually. But where it says 34, of course it's being fed directly from the solar panel, and the battery has essentially disconnected itself. What's odd is that the battery will have disconnected itself in a charging sense, but it shouldn't have disconnected itself in a discharging sense. I suppose the point is this voltage is higher. Yeah, I don't know that the Antminer's terribly happy with this. I'll turn it off for the moment, which I can do there. Oh, off. I'll have to think how that's going to work. Yes, I think I'll need to partially cover the panel. Right, panel partially covered. Let's turn this back on. The miner comes up. I'll see if it goes through its full boot sequence now and starts pulling from the battery. Back in a mo. Okay, the miner has gone into its fan test phase, and at some point it'll start pulling its 300 or so watts, 270. Is it doing it now? It might be. 24.8 there. And then this is been programmed to drop out at 22.5. So the miner will now take a slightly reduced current because the fans run down, but the hashing chips takes the bulk of the current. So that's okay. Yeah, that's and then the buck converter will warm up. So yeah, I'm just gonna have to play with this and see if it works. Right, I've uncovered the solar panel, so that's going to hold the whole thing up. So it's quite possible that this would mine continuously, or near continuously. Actually, the solar panel is producing 203 watts. Yeah, the miner's probably pulling more than that. I'll go roaming actually, because I can't really see what's going on. So there's the miner, that's pulling about, I think from memory, 270 watts. We could do with a watt meter in this path here. Perhaps I'll do that. What's coming in at the moment is 26 volts, 7 amps. The sun is out, you can see that from my bench there. And that's giving top right 202 watts. So yeah, the battery is holding up because of that. Well, there's no sense in shading the solar panel because I really want this to mine for as long as it can on solar. I mean, if a cloud comes over, it's going to allow this voltage to dip, but hopefully not so much that this relay will drop out. Just want to see if that relay's hot actually. Ooh, it's warm. Yeah, that's warm, with probably almost 10 amps going through it. Oh well, we'll see how it goes. That was a bit alarming. The display has just gone off, but I remember reading that there was a 5-minute timeout or something. Now if I press stop, what's going to happen? I think you have to press and hold stop to change that, but stop might stop it, so perhaps I won't. I mean, I do have another voltage thing on here, so 25.0 volts on this little checker, so that I could use instead of that. Oh well, I wasn't brave enough to do it on camera, but a single click of the stop button brought the display back on. And actually, I think if you press and hold this, you can put it in a mode where the display stays on continuously. Yes, I didn't mention that. It's quite a nice feature actually, isn't it? So the only alarming thing here really, apart from these exposed bolts, I'll do something about that, is this relay getting warm. That's not ideal really, but this does have that switched output which could drive another relay. And in fact the other two similar units to this, one of them has a 30 amp relay, so that might be more suitable for this setup. How's the buck converter? Yep, that's just warming up nicely. I was just looking at the correlation between this display, 24.5, and the balance checker, the battery checker display, 24.7. The lowest cell is 3.01, so we're just about to head into the 2 point somethings region, and this correspondingly is going lower, but this is set to 22.5, so I'm waiting for that. I'll put this back. Actually no, that's quite a good display, because I know which is the lowest cell. It doesn't really matter which is the lowest cell. There is quite a difference between, you can see the average is 3.09 and the lowest cell is 3.0. This battery is getting quite considerably out of balance, and yet I did completely top balance it. And I think that's because of the springiness of these cells. I'll have to come back to that, but I've just got this feeling that these cells are electrically springy. But anyway, yeah, so 2.99 on the lowest cell, 24.6 there, 24.4 there. It's not bad correlation. Not too bad. This does seem to measure reasonably accurately. That relay is still warmer than I'd like it. I'm thinking 30 degrees. Yeah, possibly a bit more, 35 maybe. It's just a bit warmer than I'd want. 2.98 there now, 2.97. So I'll come back when this is getting down, well, when this display is getting down towards 22.5, and we'll wait for the relay to drop out. This is varying quite a lot. I'm seeing up to 400 millivolts of variation. 23.6, 23.5 now, up to 24 it was, it's not anymore. And I'm just 23.9 there, so yeah, 400 millivolts of variation. Just wondering if it's noise coming back from the buck converter. It's more likely actually variations in power being drawn from the Antminer. But that's fine. 2.60 on the lowest cell there. Yeah, just waiting for this to get down to 22.5, and I'm just checking the earnings on my Chromebook, so I'll just have a look at that. The battery in my camera ran out and the power bank that it's connected to was off. I didn't notice. The sun's come out on cue, 90 watts coming in from the solar panel, so that's going to lift the voltages up. But I want this such that the hysteresis is sufficiently wide, so I've set it to 27.5, that even with a full-on, oh, there's 4 amps coming from the panel, 106 watts, even with full-on solar, this wouldn't flick back on again, because that would be a mistake, because these are not very well charged. Maybe that upper limit would have to be raised a little bit. Now, do I have enough faith in this system to just leave it here? Overnight, nothing's going to happen, of course. This display will blank out because of the timeout, which is a good thing, I suppose. I've been leaving this thing on, actually, day and night. And, of course, this is OLED, and OLED tends to suffer from burn-in, so these light-emitting diodes will gradually reduce in intensity. But that should be fine. These are only about £15, I think, so could get another one if it burns out, but so far it's been fine. Yeah, so I mean, this is just now the solar panel is charging the battery. Cell voltages are coming up. As I say, the battery is way out of balance, so balancing is something I need to look at yet. Balancing achieved by this BMS, which is just out of shot, is hopeless and not worth worrying about. So we need something a bit bigger than that. But yeah, I mean, something like this voltage trigger board, or this one possibly with an external 30 amp relay, would even be better, I suppose, to have MOSFETs. It's raining now, can you believe? The sun's out and it's raining. Weird. Yeah, MOSFETs possibly rather than a relay. I don't know. But anyway, that's the video. It was about this. Next step, don't know, whatever turns up in the post. But for the moment, cheerio. This is worth documenting. We're pushing 170 watts from the panel now because there's just a little bit of a clearing in the sky. And that's pushing up to 27.1, which is not far off my 27.5 upper limit. Maybe I need to raise that to 28 or something. Yeah, I've just raised the voltage on here, the on voltage, to 28 volts. The sun's fully out now. There's a little bit of blue sky, and the cell voltages are being pushed up against their springs, their electrical springs, because of the current, 5.7 amps. Yes, interesting. I'll just oh no, I can't because there's no power in the camera. But I did see about 8 amps briefly on the display for the solar panel, but it's dropped back, and that's because the voltage has fallen back because the panel's actually warming up because the sun's been on it for a while. So that's interesting. You can get bursts of really high current, which will push these further up against their springs. And what we don't want is for this thing to trigger unnecessarily just because there's a lot of current pushing these cell voltages up. If the current falls back, and if the panel warms up and therefore its voltage drops, so overall power drops, then these cell voltages will fall back a little bit and we won't get a false trigger on here. Yes, getting this balanced is, well, no, I don't mean the cell balancing, I mean the balance of the upper and lower trigger points is quite interesting.